Hello, everyone, and welcome to another edition of Vega Insights. I'm Luke Bideaux. I'm the president and CEO of Vega Imaging Informatics. With me today is Herman Oosterwijk. Herman is a leading expert on DICOM, FHIR, and imaging AI. You can find him on LinkedIn. Herman, it's an honor to have you with us today, and we're going to be discussing a topic that's really important for IIPs to know about as they begin implementing modern AI-powered systems. So before we start talking about the impact to FHIR on AI, maybe you could just give us a brief overview of the architecture for those that aren't that familiar with FHIR.
Yeah, thank you, Luke. Yeah, happy to be here. Yeah, let's talk first a little bit about fire because I'm not sure whether everybody knows what fire is and how it is and what it entails. And but before I start talking about it, let me tell you the story how I got involved in fire. And so when I noticed fire, I go to I used to go to several of the HL7 meetings. I thought, okay, I need to take a class on fire. So I took my first class. I came out there and I didn't get it. I thought, okay, I don't understand what's going on. So I thought, no problem. Over a few months, I go back to HL7, I take another class on fire. And guess what? I still didn't get it. So it took me three times to really understand the essence of fire. And the reason of that is because, first of all, I was a little bit biased, because I knew a lot about HL7 version 2. And, fire is so different. And second, actually, not to be, negative or something, but, you cannot really explain fire by going for the fire standard. It's almost like, you throw the DICOM standard to somebody, say, hey, figure this out. So after three times or so, I started to get it. And fire is completely different than if you're used with version 2, for example. And what is the difference? Well, no, it's a 7 version 2, which is, the current mode of operandi that everybody uses. And it's a 7 version 2, every transaction is based on a real-time event. So what would be the real-time event? Somebody comes into the ER, or, physician places an order, or a nurse takes some measurements like blood pressure, for example, right? That's an event. As a matter of fact, I was just looking at it not too long ago. My wife, Johanna, she had to go to the ER, and she happened to have an appendicitis. And I was watching the nurse, and okay, she takes a measurement, take the blood pressure, and da 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 da, on the computer, bang, an HL7 message would go along. Doctor comes in and he said, "Oh, your wife is in a lot of pain. Nurse, why did you prescribe da 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 medication?" Bang, right? Every HL7 Vision 2 message is based on a real-time event. And you can also think about it as a push mode. For now, what is the impact? Because we have different versions, not only we have different locations with supposedly the same information. Typical hospital might have, I don't know, 100, 150 applications, anywhere ranging from, air conditioning to patient management to bed management to dietary, and of course, departments, radiology, cardiology, laboratory. And on the average, typical hospital, there might be at least 25 copies, 20 to 30, or probably 25 copies of patient demographics. So what happens if you use version 2 like today, and we find out, oh, when my wife was went to the ER, they misspelled the last name, which is not uncommon because my last name is a little bit hard to interpret for many people in the United States, English-speaking countries. And so we have to update it. So nurse goes to the computer, updates it, bang, push out to 25 different locations, right?
Wow.
So
Yeah.
that's the traditional push model. FHIR, completely different. Pull model. When needed, the patient demographic is pulled from a single resource. That's always up to date, because as soon as it's modified, where is this patient database, right? Is is always up to date, is updated, and from now on, anybody, any application, real time pulls that information using a web-based protocol, a web-based link. So can you imagine the major advantage? Instead of updating 25 copies of patient demographic, or even more, let's say we have some examples. Let's say there's a major hospital, say like Kaiser or Tenet or somebody else, right? And they have or like let's say HCA. HCA has a headquarters in Nashville, and I happen to know that their centralized patient resource happens to be in Nashville. So if I live in Dallas, if you go here to one of the HCA hospitals, um, you want to retrieve the patient information, it goes straight to the resource central location in Nashville, Tennessee. Always up to date. And it took me a little while to get it. It's a pool model. It is completely based on web-based services. So the protocol used, the put and the get, whatever it is. A lot of people that come straight from university right now, college, and they have some experience with programming. They know how to do web programming, so it's very convenient, right? And coded in web-friendly web-friendly language, so to speak, JSON, XML, but most of the time JSON. And it is always accessible using these web services. So completely different architecture. Instead of push sending to multiple, and instead of having to have multiple locations, you always pull in the latest and greatest. And that's the nice thing of the FHIR architecture, right?
Yeah. Kind of reminds me of just surfing the web. If I go to yahoo.com, I'm going to get returned back whatever that web server is hosting at that moment, right? The most up-to-date
Right,
information,
right.
um, as opposed to always having websites push information out to me. So,
Yeah, yeah.
yeah, it does seem like the modern way of getting the latest data on that patient.
Okay.
So, how does FHIR relate to imaging then? Can you give us some examples of that?
Yeah. No, you could even go as far as deploying FHIR on your, let's say you have a workstation, right? A workstation, and you look at images from the PAC system. And you could even go as far as when you look at the images on the left corner, there might be patient information like John Smith. And you could be as far as having that pulled real time from the patient resource. Because you're probably, if you're a little bit, as an IAP, you're probably a little bit familiar with, okay, we need to update the patient information. Do we do it in the database? Do we also do it in the header or not? No, just the most up-to-date information could always be pulled from, that patient resource. One example. But even more important, we have orders typically that we like to pull. For example, information on the work list or in the header is not quite accurate or not mapped very well, or there's some missing information. Good examples are the procedure codes, right? Procedure code, the procedure description. And unfortunately, we used to have very good modality worklist providers, and there's still some couple out there, but a lot of the risk systems have gone away, and a lot of the EMR systems now provide the modality worklist, and they're not as nice, not as good as we used to have it. So there's some mapping issues right there. So we might, in many cases, we like to get a copy of the order, and then this order, right, would now be provided by we call it resource, basically a unique, URL that gives all the information about the order straight to the PAC system. No, and of course also the results. Results is typically in a version 2, if you're familiar with that, will be an ORU. Now we can update a diagnostic report, for example, and we can update it in a web address. And the report is actually a good example because always a problem, because we need to have the report on the workstation. Well, where does it come from? Some PAC systems would actually say, well, I just want to make sure we always have it. So we create a report, we make it into a DICOM SR. So this goes to the study. Oh, you don't have to do that anymore. Or sometimes the report is in the EMR, sometimes in the document management system. Sometimes it's in the voice recognition system, and then it might only be there for 3 years. Afterwards, you have to go to the EMR. So reports is a really good example where we have also multiple copies. And then let's say the report is updated by the staff radiologist because the resident, overlooked something, always up to date. So reports is a very good example as well. So input orders, reports is a good example. And if you get a little bit further, like I said, the patient resource, but access to a VNA, Vendor Neutral Archive Enterprise Imaging system. Several of them have now already the FHIR resource where we actually can have a link to the images. Now, do we want to pool these images of FHIR? No. We use a DICOM web, right? DICOM web is kind of the equivalent to FHIR. And I like to make an analogy of how that kind of is the same, but it's still different. So if you go to Amazon, for example, you want to order something, you can either click on something and let's say Amazon comes with a truck and delivers it with an Amazon truck. Now, if it will be an image, you won't get an Amazon truck, but you might get a UPS with basically like a DICOM web communication. But we use the same framework, the same web services, the same portal, so to speak. And so several VNAs already have the resources that provides information back to the images with all the unique identifiers and so
Right.
on. Yeah.
So let me make sure I'm understanding here. If I'm building a modern system, maybe a new AI powered system,
Right.
um, I now have the choice of building it in a way that's going to speak HL7 v2 or FHIR or both. On the FHIR side, if I'm going to create some kind of work list solution, for instance, if I want it to be FHIR enabled, my work list should go out and get the orders instead of just waiting for orders to be pushed to me. I can have it on a timer, maybe it refreshes every 30 seconds or something, and I go out
Uh,
and get the orders that the resource has made
uh,
available to my
right.
worklist
Yeah.
solution. It's same kind of with, you mentioned if I'm going to build something that has a viewer and it's going to show a little patient explorer area where the patient information, demographics, and other clinical information exists, I can pull that on the fly from the HL7 FHIR
Right.
resource that
Right.
can give
So
me that.
it's really it's a URL, but it's actually there's some within web services you have different options. You can actually register and you can get regular updates. For example, think about it as using the maps or the Waze. Maybe Waze is a better example. So you drive along the road, and then suddenly there's an accident somewhere, or
Hmm.
so you get updates. Now, uh, one of the I mean, it's all sounds really good, but one of the challenges or one of the potential issues with FHIR is that what happens if we don't have connection because typically it's accessible through the web, but what if the web is down? Let's say the cloud is down, or so we have some potential for me not be able to pull that information. So again, I take another analogy. Let's say I use LinkedIn quite a bit. I need to know, I like to know what's going on with my recent posting on LinkedIn. So I say, okay, is there any comments? And so let's say my wife is driving and I'm going to Colorado to my cabin there. And suddenly I go through this valley and I don't have connection. So I click on LinkedIn and bam, I don't have any information. Now, if I click on Facebook, I still see the most recent information. So Facebook, for example, caches certain information. So we want to make sure that in our architecture, so we have a certain level of caching. For example, remember Microsoft was down a couple of weeks ago. People couldn't really access the information, and imagine your patient resources hosted in Azure. You wouldn't want to make you wouldn't want to have the issue that you couldn't access information. Actually, as a matter of fact, at the last, I think it was SIP meeting, I talked with a PACS administrator, with IP person that says, well, we were a little bit worried about cloud because remember the Azure going down and we couldn't really register any patients. So we really need to revisit it. Well, I think I wouldn't say, web-based services are wrong, but you need to make sure you have the right architecture with backup, caching available, so you never directly impacts, that you want to do business. So that's a potential challenge that you have to take into account. Although it's not necessarily, so much different than if we had the V2 system. We all know that. It's kind of interesting story. I walked in an IIP tax administrator office one time, and he looked at his desk, and in the corner there, all down, he had a monitor and a shield, this thing for going back and forth the screen. And I said, "What is that?" He said, "That's my HL7 feed." I said, "So I cannot see that. Do you look anything?" He said, "No, but if it stops, I know I have a problem." So that's the same thing, because then
Yeah.
he stops. Okay, oh, I don't get any ADTs. I don't get any feeds from my motors anymore. I better figure out what's going on, because before you know, half an hour later, I get these calls from all my technologists that don't have work list anymore, my CT and my
Right.
MRI and so on.
It's an
So
interesting counter
you have to do the
argument
same
there
thing.
because you could make the argument, well, FHIR is completely dependent on the network, and then when the network goes
Yeah,
down, you can't operate. But you're right. Without
right.
the network, your HL7 V2 pushes aren't going to work either.
Yeah,
So,
it's the same. I fire will um, be scaled differently. Let's say a local HL7 feed, 2 feet might come from EMR, or from your RIS, which is local to a hospital, or whatever. It will probably come in many cases from much farther locations. Let me give you another good example. So here in Texas. I live in Dallas, Texas, and so one of the things that not necessarily maybe needed for imaging, but when they want to do a patient referral, they need to know a list of all the providers. Now, where are the providers? There's a FHIR resource in San Antonio, Texas, at a big health information exchange that gives a list of all the providers as a FHIR resource for anybody who wants to access it. So I think, and then like in the earlier example, the patient resource might be in Nashville, Tennessee, instead of being here in Dallas. So the scale is a little bit different. So you have to be a little bit more careful, double be as careful actually with providing caching mechanisms and having some potential, backups in the same. This is actually not much different than enterprise imaging strategy. Everybody says put everything in the cloud. Well, in certain cases, you might have a little bit of a hybrid system where we do some local information as well. So, yeah.
mhm, mhm. Now I'd like to go back to the concept of DICOM web. Um, Clarify for the audience, is DICOM web under FHIR? Is it part of FHIR? Is it separate? Can you talk about the
Yeah.
relationship
So,
between
yeah.
DICOM web and FHIR?
So, DICOM Web, you might have heard about it, maybe not. But so, DICOM Web is a replacement of the DICOM protocol, but we used to be called traditionally DIMSI, DICOM Image Message Service Element, DIMSI. DIMSI is the protocol that people use, let's say, on the CT scanner. The CT scanner wants to connect to the PACS. It opens an association, we call it, connection. It says, I want to send CT images. It gets a response back. Sure, send them over, and he sends them over. And so you might have seen sometimes these log files with the she stores, she finds, she gets, she move, and whatever. And these are all DIMC commands, DIMC
Mhm,
commands. And that's not going to change, because all these CTs, MRIs, ultrasound, nuclear, all these modalities have implemented it for 20, 30 years, and they have solid toolkits that everybody knows how to use. It's ingrained in there. Why change something that works? People tried that with HL7 version 3, so let's change HL7 version 2 into 3. And then people said, well, why would we want to do that? Because we don't have the same reliable toolkits, and it's no return on investment yet. For the enterprise solutions, for example, I want to now have access to images anywhere, any place, using my phone, my tablet, any computer that has access to the internet. And that was actually like kind of a revolution. Just another anecdote. I installed an open source PAC system in Uganda, and we had a portable X-ray there. And then I go to the physician, and I said, "Okay, take your phone. Okay, well, type in this URL. And bang, here's an image." He says, like, "Wow, wow, this is amazing." And that is what DICOM web. That happened to be a viewer, a DICOM web enabled viewer that also can run on a phone or on a tablet. So DICOM web allows the use of browsers or web services to access this. So that's where DICOM web really has a really important place. Now go back to make a little bit to AI. Where would you use DICOM web in AI application? And most of the AI imaging applications use the cloud. So let's send the images to the cloud, and we do, I don't know, AI for breast cancer detection or for fracture detection or stroke detection, whatever it is. So we send it to the cloud, and how does the cloud work? Oh, with a web address. So most AI applications in the imaging space today use DICOM web because it's very convenient. Because what else does web services provide? Security. We have a problem with security a little bit. Some of the hospitals said, "Well, we need this, we need this completely be secure. So we even want you to encrypt the information going between a CT scanner and a PAC system." How you can do that? You can use DICOM secure TLS connectivity. Has been demonstrated, has been defined for many years, has been demonstrated, tested, and connected. What is the problem with that? You need a certificate. Are you seeing a CT scanner connected to the web to get a certificate from VeriSign or something? I don't think so.
No.
I mean, that creates more potential security threats than being able to encrypt the data. Now, web services, DICOM web, piece of cake, right? You just use HTTPS. Anytime you go to Amazon or Airbnb, whatever you use for online services, and as soon as there's credit card, okay, HTTPS, everything is automated. So security is kind of free. Uh, Free. So you get the secure connection. If you want to use DICOM web to upload your images from the AI application to, let's say, Google Cloud or somebody else, they run the AI application can run the AI algorithm, send back the result in the form of a, I don't know, secondary capture image, AI result, structured report, presentation state, or encapsulated PDF. All of these different versions of AI results that unfortunately are available today. They're still thinking about some standard implementations, and IT is kind of working on that. But anyway, so these AI results will come back over DICOM web. So DICOM web is very powerful, and you see the most in uploading and connection to cloud systems and also to enterprise imaging systems. And if you think again, FHIR and DICOM web, the protocol is identical, right? When I take my protocol, you do your commands. Instead of a C-store, you do a put in or you do a get or something, right? So the protocol that we use is the same. So again, I go back to my analogy on Amazon. Amazon, if you want to buy something, you have a single portal, and we use the same communication, basically mechanism for connecting to those web services. The transport mechanism is different because when we need to pull so pixel data and DICOM image, for example, we use a little bit different, and we cannot do that in FHIR either. That always has been the main differentiator between HL7 and DICOM. Just another anecdote, I had CIO asking me not too long ago. He said, what is this DICOM stuff? Why don't we just use HL7? I said, HL7 is text.
Right.
We don't access text, we have pixels.
Right.
Pixels that need to be identified with how many bits they are, what color space they are. Do we apply a lookup table? What pages do they belong? That's not something that HL7 does very well. And he kind of like, oh, I guess not. So it's a very different standard from a data formatting perspective. There's another thing, by the way. So FHIR FHIR is still text-based. And as a matter of fact, interestingly enough, if you look at the FHIR methods, that's actually a requirement to have a text representation. So even if I wouldn't be able to understand the complete, let's say, patient resource or whatever resource we have, you can always go back to some kind of basic text. Very important when we when we talk about clinical important information, such as a lab result. Let's say I don't have the code for my white blood cell count. I cannot interpret it, but at least there's text that I can interpret. So we have always the right information. We're going a little bit off imaging again, talking about lab results or whatever, but just the idea of FHIR, being really text-based, like so patient demographics, reports and stuff, is very good for that. Yep.
Right. So you're saying that FHIR and DICOM Web use the same protocol, and they use RESTful services, right? That's
Right.
what's similar between
Yeah.
FHIR and DICOM Web.
Yep.
But FHIR is text-based, and DICOM Web allows for the transport of images, right?
Right. Or
And
DICOM objects.
specifically DICOM objects.
We always talk about the images, but we forget that we have
Could be
encapsulated
other types
PDFs and structured reports.
objects. Okay. So just so I'm following on the DICOM Web. So um, like with FHIR, there is a resource that supplies the object and
Access to the object, yeah.
right access to the object, and then you've got the other application that's doing the pulling, putting in the request in a secure manner using RESTful services to pull the DICOM object in, um, and so just like we were saying before, rather than waiting around to be sent things, you can pull whatever you want on demand and always get the latest
Yeah, we
version
can
of
get a
that output.
subscription, whatever the web services provide on services. Yeah.
So to try to tie it into some more real world scenarios here, um, let's talk about um, prior reports. You mentioned that um, currently with HL7 v2, when a report's created, there's an ORU message that could be going out to 20, 30 different downstream systems, right? And with FHIR, uh, there's really no need to be doing all that pushing around. You're
Right.
gonna get the report into the main source of truth system, and then any other system that needs a report at any given time
Yeah.
can do a call and get that report. It sort
Yeah.
of eliminates to me the need to preload data, or even could eliminate the need to do migrations in some use cases,
Yeah. Yeah.
right? So if I'm building a new system that needs access to prior reports, a lot of these new AI-powered reporting platforms have functionality where they can compare with prior reports, right? So
Yeah.
one might think, oh, okay, you got to migrate all the prior reports in before you get started, and you got to keep it in sync. But that's not the case, right, Herman? With
Right.
FHIR, you can just get started on day one and you open the first patient. On demand, you pull in all the prior reports you need using FHIR, and then your AI
Yeah.
system can work with all those reports.
So you can imagine how fundamentally the architecture could change, right? And probably the ultimate change could be even at the electronic health record, at the EMR. An EMR could be a skeleton, like a template. Patient information, click on the patient resource, which is centrally located for the whole, enterprise. The doctor's information go to a statewide resource. Lab results go to, I don't know, let's say they use Quest, right? Goes to the Quest database, right? I was thinking about it when I when I visited my doctor. He looked at my lab result and he uploaded a PDF in his own EMR. Oh, you just need a link to to Quest or
Right.
whatever it is, or LabCore or whatever you use. And then of course for images there's another link.
Mhm.
For documents, um, Yeah, I know some big hospitals, they used to have document management systems for scanning all the reports and stuff like that, and all the documents, release forms. Some of these big document management systems, they have FHIR interfaces right now, so you can upload the diagnostic report there as well.
Hmm.
There are some interesting overlaps, and that goes back to what is a document and what's not a document. For example, what is an EKG, right? Some hospitals put it in a PDF and it becomes a document. Some create a DICOM, a DICOM EKG object. More and more they do that. But really, again, it doesn't matter. Either it's accessible to wherever it is stored, whether it's in a document management system or whether it's in a enterprise imaging system where we store EKGs in a DICOM format, for example. So, a unique web-based, accessible, unique identifier. Well, yeah, this definitely gives you a big opportunity. So if you would start from scratch building a hospital, and you have and all the vendors will be available, you just have a couple of resources. You
Yeah,
probably can eliminate, I don't know, a lot of complexity and duplication.
I
You
think
could
that's
probably downscale everything
the
multiple times.
key is
Yeah,
if you were starting from scratch, which many new AI startups, they are starting from scratch, right?
yeah,
So
yeah.
you would use Fire if you had the
Absolutely, there's
choice,
no
right?
question. Yeah.
So it's not that Fire is necessarily going to replace the
No,
existing HL7 interfaces, over the next couple of years, but new systems that are being developed may primarily support Fire, and that may need to be. So if you're in a role that's in charge of implementing new systems and you don't know Fire, you could be in trouble here.
yeah, you really need to really look a little bit ahead, and you ask, when you get a new application, so what do you do about fire? And even if you wouldn't use it today, you could use a converter, but don't convert HL7 version 2 transaction into fire transaction because that completely defeats the purpose. Because then you create a non-current, timestamp, so to speak, that defeats the purpose.
Someone
So
just do it just for
yeah,
the sake of trying to
yeah,
migrate to Fire, but if you're interested in maybe implementing a new architecture, a modern
right,
architecture, and that might be a time to
yeah,
think of a new design. I think about you were talking about the links in the EMR. Um, it was such a process to get the EMRs to be able to access the images. But when you think about what we've implemented in most cases, it's not really that the EMRs are accessing the true images. What's happening is you're clicking a link, it
I know.
loads the PACS viewer, and then you're accessing the images through the PACS. With DICOM Web, if you were going to design that now with DICOM Web, you could build your viewer, go with your best of breed viewer that you
Yeah,
like,
yeah,
and actually
absolutely.
pull those images into the
Yeah,
viewer
yeah,
so that
yeah,
you're
yeah,
truly accessing
yeah.
those resources and bringing in the images. So, um, yeah, that's interesting. So, any other main challenges that people need
Yeah,
to be aware of when
yeah.
they implement
So,
fire?
so after typically we talk about fire, everybody gets hyped up and
Yeah,
excited and say, let's do it. And there's always good and bad news.
yeah.
And I wouldn't say necessarily bad news, but things to be really aware of is that fire is immature. Immature. What do I mean by that? It's still, I mean, we're currently on version 6. Um, and it's changing really fast. Version 4 was only from a few years ago. Most systems are on version 4 right now. And if you think about Fire as a standard, and you think about Fire as a standard release, like for release 4, 5, and 6, inside Fire itself, there are these resources: patient resource, diagnostic report resource, provider resource. In imaging, we need a handful, maybe 6 or 7 or so. But overall, in the whole hospital, we have about 100 or so, 100 plus of those resources. So each Fire release has multiple resources, and the resources have a different level of maturity. And that's when I say FHIRs are mature, because the majority of these resources are immature, meaning they're not at a maturity level that does not guarantee backwards compatibility. Okay, so if I'm on release 6 and you are on release 4, right? There's there could potentially be an issue with compatibility, and so that's probably the most. I think the most number one challenge. Make sure that you are on the same release version, because it's not always backwards compatible. The second, and I don't know whether it would be a challenge, but the resources themselves, the content of the resource, let's say patient resource. In these resources, we have patient name ID, birth date, sex, and everything. And think about this resource as a segment. Segment, if you're familiar with HL7 version 2, a segment in version 2. So there will be the PID segment. So patient name ID, birth date, sex, address, whatever it is, right? And so these resources have attributes, but they are not required. They're not required.
Mm.
So there was a very conscious decision made to make HL7 FHIR very few restrictions and have the capability to have a machine readable conformance declaration. So I could actually deploy or actually make an application, say, okay, I'm going to go, if I create have to create my patient and information little window, I'm going to dynamically pull the conformance declaration from the FHIR server, because every FHIR server is required to have the conformance declaration, the conformance standard. I could pull it dynamically and find out that the patient name has 3 components: last name, first name, and mother's name, for example, and then automatically configure it. But it makes it a little bit complex. And of course, there's some advantages. Let's say I'm familiar with Norway, for example. You actually can Google Norway FHIR conformance and declaration, and then you can say, okay, Norway, we have a universal patient identification and this and this and that. So there are standard conformance. The same thing with the United States. Um, Different countries, different organizations, like a Department of Defense might need to know the military rank. No, nobody else cares about military rank except if you have a system that is deployed in the VA in the Department of Defense or something, or the branches, the military branch. Yeah, no. So in their file conformance, it would say we need to have the branch, we need to have the rank, and so on, right?
Yeah.
So I would say necessarily disadvantage or challenge. So it's something that you have to be aware of, and you have to, um, make sure that you are implemented correctly. And it's work. It's work. Yeah, but there was a
Yeah.
conscious decision made for that. This is a design, the architectural decision.
I think about the headache it is to do a new HL7 V2
I
integrate. They're
know.
definitely not plug and play. I mean,
Yeah,
if a word comes out, okay, we got to do a new ORU interface with this. It's going to be
yeah,
like, oh, let's get both vendors on the line. Let's get our HL7 interoperability team on. This could be a 3-month, 4-month project, and
yeah.
it sounds like with FHIR, while
You
it's
just
not
pull it.
exactly plug and
Yeah,
play, you have this conformance object that you can pull and you
yeah. It's
can
required.
design
Yeah,
according to that without needing to get the vendors involved.
absolutely.
And
Yeah,
so
it's almost like
FHIR engineers have a lot more power to do
yeah, yeah.
integrations, it sounds like,
It's
independently.
almost like in the DICOM world, where we have a required DICOM conformance statement. Unfortunately, they're not machine readable, so you have to go for all the pages and find out the subclasses and da 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 da. Transfer syntaxes, does it do compression, yes or no? So, but this is now all automated. So it's machine readable, XML, JSON, and there's a template to find. So you could potentially dynamically ingest it and parse it. So that's good.
Yeah, that's great. Well, Are there any useful resources? I'm sure that
Yeah,
a lot of people, interested to learn more. What can I do as an IIP to build up
yeah.
my skills in this area?
Yeah, thank you. That's a good question. So, FHIR, it's web-based, so everything is online. You don't need
Mhm.
necessarily any paper to deal with FHIR. If you want to know a little bit more about FHIR, and what I always find is the most useful is play around with it, like having a sandbox. Now, the good news is that SIM, I'm sure everybody's familiar with SIM, Society of Imaging Informatics and Medicine. They have a FHIR server that you can use. And if you don't mind just pulling up a
Yeah, let me
resource,
share
and
here.
they use it at the hackathons every year at the SIM annual meeting. There's a hackathon. So you can go, you can hackathon servers, you can click
Mhm.
at it, you can
And
play with
click
it.
here. Uh-huh.
Uh, yeah, see, before we start, using the hackathon server, and you have to register because they want to make sure who's doing what. So that's very useful, very useful. Um, Playing, and particularly if you want to learn a little bit more. Now, it's a little bit, um, no, I wouldn't say a little bit. You need to know how to use, Postman or some kind of a user interface or GUI tool to be able to access the server, right? Um, Another very useful resource would be an open source FHIR server, and there's several of them. Um, the one I like personally, and that I usually use when we used to do the training for FHIR, is Happy. Happy is a server right here. And the nice thing about Happy is FHIR. It's Canadian. You can actually download it and install it on your own server if you want to. And also, if you want to play with it, this is probably the best way to get familiar with FHIR because it has a very rudimentary interface. For example, on the left you see a list of the resources. If you click on, let's say, patient, right, patient resource, you can actually do a read. Basically, you will see exactly. Oh, ta-da! So you can well anyway. So you can actually let's take another one, maybe observation, right? Observation resource. You do search,
Mhm.
and then you see exactly what go out. See the request, the response, and then it gives one of those resources. There's quite a few entries. You see like I don't know 40,000 or something. I cannot really see right now. So looking at this text, you can actually change from XML to JSON. I find XML a little bit more readable. So you can play around with it. You know exactly what's going on. So I like this as for learning how to do it. See JSON,
Mhm.
XML. I really like this a lot. And so you see the command request is a get command. Uh, so that's really helps a lot. Now, if you want to get an idea of what's in the standard, you can go to the HL7 FHIR website, right? So here's the HL7 FHIR. Uh, this shows all of the resources, right? So if you go down a little bit, you see there's the second block, and that says individuals, and there's a patient. See patient there, patient right there.
Mhm. Mhm.
Okay, and then you click on patient and you go down a little bit, and it gives you exactly the difference of the definition of what's in the patient. Patient identifier, the name, the birth date, the sex, da 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 da. It's almost like, it's a subversion to old standard. Now, if you go back, if you don't, oh yeah, that's another thing. They give examples. They give examples. So it's really, really, really cool.
Yeah.
Now, if you don't mind, go back to the list of all resources. I just want to highlight one thing that I mentioned before. Remember, this happened to be a release 4. That
Yes.
said that within a release, a file release, there are multiple resources. There's about 100 or so of those, and it gives you different maturity levels of the different resources. So patient, when we look at patient, it has this capital N, and the
Mhm.
capital N means it's normalized. So that means it's the level 5. This is a mature resource that is it's not gonna. They're always gonna have backwards compatibility. But
I
see
see.
how few N's
Yeah.
there are, right?
Not
See?
too many.
And,
Uh-huh.
yeah, and if you look at the imaging, a little bit of clinic, it's under clinical, but you'll see that some of the ones that we want to use with an imaging, like a diagnostic report, is not quite N yet. So maybe it's in release 4, 5, or 6. I'm not sure which one, but it might be not till 7. Till it is normalized resource. So that shows a little bit the. I wouldn't. I don't like the term immaturity, but it
Mhm.
shows how mature some of the resources is that you have to be really careful. So if you would today implement the patient resource, absolutely, go ahead. You should do it. If you
Mhm.
if you have an opportunity. But some of the other ones, you could do that, but you have to be prepared um, to make sure that you upgrade it over the next release. So yeah,
Well, that's great. Yeah, I appreciate you sharing those resources, and I encourage the audience to check those sites out and play around.
yep. No better way to learn than to play with stuff. See is believing. So
And there are resources out there you can go to for training. Sim has training. Vega is now offering training. Many places online you can go, or just YouTube and ChatGPT and things, and learn as much as you can. Position yourself to be ready for the future, and certainly FHIR is going to be there. Um, just want to thank Herman again for taking the time to walk us through all of this. I think it's been very informative, and we look forward to speaking with you again soon.